Okay, so this is question 9, higher level junior cert, paper 1 of the mock exams. Jason makes a sequence of a certain number of lines arranged in a pattern. The first 3 stages of Jason's sequence are shown below. The sequence starts at stage 0. There are 6 lines. So there's 1, 2, 3, 4, 5, 6 lines. Okay? Then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. 11, sorry, there's 11 lines. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 lines here. Okay, draw the next stage of Jason's sequence, but could probably spot that there should be kind of like a 4th little house there. 1, 2, 3, 4. Okay, so there's 21 lines in this one here. Jason thinks the sequence is linear. He is correct. Give a reason why his sequence is linear. Well, if you look at it, it's 6, 11, 16, and 21. And they go up by 5 every single time. Alright, so my answer is yes, because the first difference is common. So that's the mark of a linear sequence if the first difference is common. So the first difference every single time is common. Using a graph, a table, or otherwise, write a formula to express L in terms of S, where L is the number of lines needed to stage S of Jason's sequence. Now I'm just going to ignore the L, the S, alright, for the moment. I'm just going to go with the way I would have shown lads, and probably the way most of us would have learned it as well. Okay, so let's look at stage 0, or in other words, T of 0. Alright, take that 0 and add the difference. Alright, okay, and when you add that difference, sorry, made a little mistake there, T of 0. So take that 0 and multiply it by the common difference, you get 0. What do I have to add that to that 0 so that I end up with 6? Well, that's plus 6. That's fairly straightforward. Let's look at it for T of 1. So for term 1, take the 1, multiply it by 5. That gives me 5. And I have to add 6 to get 11. Right? The 11 lines. Look at term 2. 2 multiplied by 5, that's equal to 10. And I add 6. Alright? So that gives me 16. Which is how many lines for this one here. So I want T of n. Right, the nth term, the general term, okay? Where I'm going to take the n and multiply it by 5. That gives me 5n. And look, every single time I've been adding 6, so it must be plus 6. All right, and there's my general term. Or in other words, the number of lines is equal to 5 times s plus 6. Okay? On to part D. Using your formula or otherwise, calculate the number of lines needed for stage 20. So we want term number 20. And that is going to equal 5 times n, in this case n is 20, plus 6, which is going to be 100, plus 6, which is equal to 106. Alright? There are exactly 71 lines in stage P of Jason's sequence. Using your formula, otherwise find the value of P. So what I'm essentially saying is that 5n plus 6 equals 71. Alright? So 5n, I take away the 6 from both sides, I get 65. N is going to equal 65 divided by 5, which is 13. So P is equal to 13 here. All right. Deirdre also made a sequence. The formula for her sequence is L is equal to 3s plus 4, where L is the number of lines required for stage S of the sequence. Below is stage 0 of Deirdre's sequence. Draw possible examples of stage 1 and stage 2 of Deirdre's sequence. Okay, so let's see. Okay, so 4 lines. So look at this one. This is the way I'd say it. For term 0 or stage 0, all right, the number of lines are 4. Okay, 1, 2, 3, 4. And that's going to be equal to 3 times the stage, which is 0, plus 4. And look at that. 4 does, in fact, equal 4. All right. So for stage 1, that's going to be 3 times 1 plus 4, which is equal to 3 plus 4, which is equal to 7. So there's 7 lines in this next sequence. 1, 2, 3, 4, 5, 6, 7. All right. 3 times 2 plus 4 is just going to give me 6 plus 4, which is equal to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And that's question, what question is that? Question 8, is it? Or question 9. Question 9 sorted.